Today we are going to learn about mastering dendrogram interpretation and hierarchical clustering. We will explore how to read and analyze dendrograms effectively to enhance your data clustering skills. Welcome to our video on mastering dendrogram interpretation and hierarchical clustering. Dendrograms are tree-like diagrams that display the arrangement of clusters produced by hierarchical clustering. They serve as a visual representation of how clusters are merged or split at each step of the process. Understanding this tool is essential for anyone looking to make informed data-driven decisions. In this video, we'll delve into the intricacies of dendrograms, covering everything from reading branches and nodes to identifying patterns and outliers. By the end, you'll be equipped with the skills needed to interpret dendrograms with confidence and precision.
Diving into the basics, dendrograms consist primarily of branches and nodes. Each branch represents a cluster, while the nodes signify the merging point of two clusters, often displayed with lines that connect the data points. The height of the node indicates the distance or dissimilarity between the clusters being joined. This height is crucial as it reflects the linkage method used, such as single, complete, or average linkage. Understanding these components is vital for interpreting the relationships within your data. Dendrograms can be oriented vertically or horizontally, though the interpretation remains consistent. The orientation simply reflects personal or software preference. To effectively read a dendrogram, it's important to focus on the branches and nodes. The length of each branch can suggest the level of similarity between clusters. Shorter branches indicate more similar clusters. Nodes, where branches converge, represent the merging of clusters. Interpreting the height of these nodes helps determine the order and significance of cluster formations. Generally, dendrograms are read from bottom to top, where individual data points or small clusters merge progressively into larger clusters. The hierarchical tree structure is not just a visual tool but a reflection of the inherent data patterns, providing insights into how data points relate. One of the key uses of dendrograms is determining the optimal number of clusters. This can be achieved by identifying natural breaks in the dendrogram where large distances separate clusters. Analyzing node heights can provide insights into where these breaks occur. The elbow method is a popular approach, looking for a point where adding another cluster doesn't provide a significant improvement. Alternatively, the silhouette method can be used to assess the quality of the clusters. It's important to consider the practical implications of these methods, ensuring that the chosen number of clusters aligns with the data's context and the analysis objectives.
Hierarchical clustering can be either agglomerative or divisive. Agglomerative clustering is a bottom-up approach where each data point starts as an individual cluster. These clusters are then merged step by step until a single cluster remains after the desired number of clusters is achieved. On the other hand, divisive clustering is a top-down approach, starting with a single cluster and splitting it into smaller clusters. While agglomerative clustering is more common due to its computational simplicity, divisive clustering can be useful in scenarios where the top structure of the data is more apparent. Understanding the differences and applications of these methods is crucial in choosing the right approach for your dataset. Dendrograms are powerful tools for identifying patterns and outliers within data. By analyzing the branch lengths and node heights, you can discern patterns such as clusters with high density or unusual data distributions. Short branches often indicate tightly knit clusters, while longer branches can suggest outliers or less dense areas in the data. Recognizing these patterns is crucial for accurate data interpretation and further analysis. Techniques such as examining the distribution of branch lengths and node heights can help highlight areas of interest or concern, allowing for a more comprehensive understanding of the data landscape. To cement our understanding, let's explore a real-world case study. Imagine analyzing customer data for a retail business to identify purchasing patterns. By applying hierarchical clustering, we generate a dendrogram to visualize the relationships. Step by step, we can interpret the clustering results by examining the branch lengths and node heights. This analysis allows us to group customers with similar purchasing behaviors, identify outliers, and derive actionable insights. By applying the techniques learned, such as determining the optimal number of clusters and recognizing patterns, we can draw meaningful conclusions that drive strategic business decisions.
Despite their utility, dendrograms can be prone to misinterpretation. Common mistakes include misunderstanding the significance of branch lengths and node heights, which can lead to incorrect conclusions about data similarities. Additionally, overlooking the impact of different linkage methods can skew the analysis. It's crucial to account for the context of the data and the objectives of the analysis, ensuring that interpretations align with the overall goals. By being aware of these common pitfalls, you can improve your dendrogram interpretation skills and enhance the accuracy of your clustering analyses. Numerous tools and software are available to aid in dendrogram analysis. Popular options include R, Python with libraries like SciPy and Matplotlib, and specialized software such as MATLAB and SPSS. These tools offer a range of features and capabilities, from basic dendrogram generation to advanced analysis and visualization. When choosing a tool, consider its integration with your existing data analysis workflows, ease of use, and the specific features required for your analysis. A user-friendly interface can significantly enhance your ability to effectively interpret and utilize dendrograms in your data-driven endeavors. In conclusion, mastering dendrogram interpretation is a valuable skill for anyone involved in data analysis. Understanding the structure, components, and significance of dendrograms allows you to make informed decisions based on hierarchical clustering results. We've explored essential techniques, common pitfalls, and tools to assist in your analysis. With these skills, you're now equipped to apply dendrogram interpretation in real-world scenarios, enhancing your data-driven insights. Continue honing these skills and exploring further learning opportunities to become even more proficient in the art of dendrogram analysis.